Hi there, welcome back to Pretty Much Flawless. Today in this video, we're going to be modifying our inverter circuit. I did a video on inverters, that'll be linked in the description down below. And somebody pointed out in the comments there's a few things I could change that make this better. So, I will do that. Let's get into it. Alright, so the first change we're going to make to our circuit here is we're going to put each transistor on their own pin from the Arduino. Alright, so here's our circuit. We have the positive up here, the ground down here, and what we'll do is we'll begin operation by turning Q1 and Q2 on. So that allows electricity to flow from the positive through Q1, through the load, across the output terminals, and back down through Q2 for the negative, and it goes to ground. So then we want to make this AC, right? So we shut off Q1 and Q2, that stops the current flow, and then we turn on Q3 and Q4. So it flows in this direction now, from Q3 from the positive over the opposite way it was going before. And that will give us not a perfect AC sine wave, but something more like this, a square wave. That the 0 volt reference would be somewhere like here. And there we go, so it goes plus voltage and minus voltage. So let's make this circuit. Alright, so now we'll explain the schematic here. So we are using a 2N3904 transistors, 4 of them, and each are fed with a 1K resistor. And with the Arduino, they're fed from pins 2, 3, 4, and 13. I was used pin 13 because it's more handy when using the Arduino Nano, but you could change that by changing the code. So, and then after, we have the 2 output terminals on the very right of the screen, and it doesn't really matter which way it goes up to your oscilloscope because they're AC. Yeah, so that's our circuit there. It uses Arduino Uno in the picture, but I'm using Arduino Nano, and you just have to change the pins around if you want to do that. Just make sure that you have the sequence right, because you don't want to be shorting it out, because that wouldn't be very good for your Arduino or your load. Alright, so here is our outputs. This is the redone circuit here, and it's similar to what a H-bridge controller would be. There'll be a future video on H-bridge controllers. Let's go redo the code for this. So, we'll explain my code a little bit. So, on the top it says pretty much flawless. That doesn't really affect the code, I just thought I'd put that in there. And we have our integers, which are variables. So we have delay 1, delay 2, Q1, Q2, Q3, and Q4. And those are all set to different numbers. And if we go down to the void setup, we have our pin mode, and there's Q1, Q2, Q3, and Q4. They're all set to output. And what that means, basically, is those pins, which are 2, 3, 4, and 13 on the Arduino, are going to be set to output. And next, we go up to the void loop, and then we have our commands for our pins. We have the digital write, Q1 and Q2 set to high. That means the pin is going to be high. And then we have our delay, the delay 1, and that will be 1 millisecond. And then we have our digital write, Q1 and Q2 go low. And then we have our delay microseconds to have a little bit of delay between the on time and the off time. And then we repeat that again for the next 2 transistors. And now we'll do explanation of why we need that delay microseconds, or delay 2. Something to have a note when having a square wave is, so let's say this is our square wave right here. This is the 0 volt reference, this dotted line here. And what we have here is this goes from positive all the way down to negative, pretty much straight down. And that can be a bit of a problem for AC, because as soon as it comes under load, this side could come this way. And what happens is then it shorts out between the positive and the negative here, and that can cause a big problem. So what you do is we put a bit of a delay in between here, like this. There's just a teensy bit of delay in my code, which we'll show later. It's 70 microseconds, but yeah, so that's what we have there, and just a little tiny bit of delay, so even when it does come over load, it can go over a little bit and still have plenty of gap room. Still, this isn't really an industrial design circuit. This is just something I thought I'd show you guys because it's a pretty neat project. Alright, so we got the circuit all wired up. We got the programming all done. And now we can view on the oscilloscope what we have here. Alright, so you're able to see on the oscilloscope screen here, this is our 0 volts reference right here. And we have positive voltage and negative voltage. And we can zoom in a little bit there. You can see that, right? Turn up the intensity. There we go. You'll able to see right there, we have a little bit of dead time. Or for some reason there's this blip, maybe that's from the transistors going off or something. And there's that little blip, and then there's just a little bit of delay time. And so that's that. Interesting. And on the negative part, we'll zoom out a bit. You can see down here that there's the same thing, only this must load down the power supply or something, because you can see it starts lower and then it goes up like that, and then that's also some dead time between here and there. And yeah, thanks for watching this video today. Hope you learned something. If you did, please subscribe. That would really help my channel. And I'll see you next time.